Hey everyone, welcome back to another edition of my video blog where I talk about Azure, data services, and a little bit of professional development. Today we are going to talk about how Azure Synapse, Azure Databricks, and Snowflake all compare as far as regular and usual data workloads perform and some use cases and things like that. Before I kick things off there, though, I want to thank my friends over at Mill5. They hooked me up with this sweet t-shirt, right? Taking IT by storm. And great group of guys over there doing some great stuff. Check them out at mill5.com. Okay, so now let's look at the sort of high-level overview of each of the services we're going to talk about today and kind of take a look at what some of those common workloads are. We've got a good handful of them here, and we'll see where it goes. So now, first things first, Azure Synapse. So when we talk about Azure Synapse, we talk about the next generation of Azure SQL Data Warehouse, or the APS, or Analytical Processing System, and Parallel Data Warehouse. It sort of had a lot of different iterations in different forms, and its roots are in that massively parallel processing engine for primarily OLAP workloads. It came out as Azure SQL Data Warehouse several years ago, and then Gen 2 came back just a couple of years back that offered a ton more performance and capabilities. But then we flash forward to just about a year ago, last November, when we announced Azure Synapse. And Synapse is the MPP engine and more, right? So now you have Spark engine that coincides with the MPP SQL engine, as well as a development interface that allows you to develop notebooks and SQL queries and some Power BI and orchestrate your data and do some transformation. We've ported Azure Data Factory as part of the interface. So it really is sort of an all-in-one solution for a variety of different data workloads. Now, when we look at Azure Databricks, we've got a different approach at a similar solution. So Databricks is primarily built on the Spark infrastructure. So when you look at Spark, it was built out of Hadoop. It gave us a way to process big data workloads in memory and do so in the open source environment. Apache created Spark initially, and the team that created Spark went and built Databricks as a company. Now, Databricks gives you the ability to optimize Spark and more. In the newer iterations of Spark, you've got some pretty significant performance benefits. And so by using Databricks and the interface and then some of the other tooling that they've introduced over time, you have, again, a relatively complete solution when it comes to data workloads. Lastly, when we look at Snowflake, this is a cloud-first data warehousing tool. It was built by folks that came out of Microsoft to be a better version of a data warehouse tool. Cloud native, it can't run on-prem, whereas you can still run some OLAP workloads as well as some Databricks workloads, SQL OLAP workloads in your premises on local hardware and things like that. Whereas Snowflake was cloud-born and cloud-only. It runs in the three majority public clouds, so Azure, Azure, AWS, and Google. And it's a very nice offering. And as we get into it, you'll see it has some definite strengths and then some definite gaps. And so it'll be interesting to see how that product evolves over time. So, jumping in, let's look at the first use case. And we're going to look at traditional data warehousing, okay? So this one's an interesting category because when we look at a traditional data warehouse and say we want to look at the 4 stages of a data warehouse where we ingest, we store, we transform or process the data, and then we serve it up to whatever our presentation tool is going to be. Starting with Synapse, it has that SQL OLAP engine running in the background. But then you've also got some of the nice interface tools. So you can do a lot of the data processing right inside the Synapse Studio environment, which is, at the time of this recording, in public preview. And we expect it to go to generally available within the course of the calendar year. So we're relatively close to that going to GA. Now it has a very familiar interface because it does have
notebooks
interface, which has been out for a few years now. You can do a lot of your data processing, and you can do a lot of your transformation and those types of activities with your data within that interface. And it also allows you to now allow for any kind of big data workloads because it has a Spark engine included. Now, it's relatively new with regard to the Spark engine, but for pure data warehousing needs and requirements, it is definitely tops. Snowflake is a similar story, except that it might actually have a slight edge over Synapse and Databricks, which we'll talk about in a second. It was designed for data warehousing. It has a great, clean, responsive, and intuitive interface. Some niceties about it are things like you can have all your historical queries, and up to a certain number just available for you. So you can rerun those at a later time. It kind of reminds me of being able to run command line commands in, say, CLI or Shell or something like that. Now, it's definitely different from the Synapse that we're used to, or SQL interface that we're used to, because it does have a more clean interface. It's more responsive, and again, it's all cloud native, so you can just use the tools that are given to you and run all of your queries and all your transformation and everything in that interface. Now, with regard to the completeness, you do need to use some other tools to bring the data into your data warehouse environment. But from a pure data warehouse perspective and serving up that data, it's a great interface and a great tool. Databricks is a little different, right? So Databricks is primarily a CLI interface. You're developing code in something like Spark or in Python, PySpark, Spark SQL, those kinds of things. Except there's some more capability coming out. They recently announced the Photon engine. So now it opens up more opportunities for Databricks, and I'm going to be curious to see where this goes. The Photon engine coupled with the Delta Lake creates this Delta Lake House architecture, which is interesting, but a lot of it is still in the early phases of preview, and we won't see a complete picture until probably the middle of next year. So from a pure data warehousing perspective, it's probably not strongest in Databricks at this time, but it'll be interesting to see what happens as it evolves over time with the Delta Lake and the Photon engine coming up to speed. Okay, switching gears, we're going to look at data processing. And so now, when we look at it from a Synapse perspective, it's definitely a strong capability here because of the porting of Azure Data Factory. It has the Data Factory elements built in, so from an orchestration and transformation standpoint, you have all of the capability of Data Factory, so you've got over 80 connectors to different sources. You can use a fair amount of transformation tools built into the Data Factory, so all the traditional ones, sorts and aggregations and those kinds of things, those are all built in. And then on top of that, you can also use SQL stored procedures if there's something that the visual elements, the GUI that ADF provides, or any of the dynamic coding environment from ADF has to offer. You can always use SQL stored procedures. In the background, it's actually running Spark for doing all of the data processing, but it's essentially translating that GUI into the code for you and running it on Spark in the background. Now, looking at Snowflake, the data processing side is pretty minimal. You have Snowpipes, which will help you move the data, but there's really limited aggregation and transformation capabilities, so it's not a great option for data processing. Now, Databricks, on the other hand, is a great option. And, this is basically a code-first environment. So one of the challenges is that your team has to have familiarity with the tools that are used there for that data processing. If you have those team members, great. That it's a great solution. It's a very familiar environment using notebooks and doing any transformation and aggregation. And really, this is an environment that's designed for a lot of heavy data workload. It runs on Hadoop file system. They actually have their own iteration called Databricks file system. And it's definitely optimized for running massive amounts of data and parallelizing the way that it's computed to output the information that you need. So, whether you load the data into a data frame or memory, or you persist the data into some kind of Parquet format, the data processing here is very capable. So, I would say they're on par with Synapse and Data Factory. Again, just looking at it from a pure development environment, one is CLI versus the other being GUI based. Okay, so next, we look at real-time data streaming workloads, or the hot path, if you will, common term that's used here. And when we look at Synapse, Synapse in and of itself doesn't have a way to process streaming data workloads. Now, it's in the Azure environment. It's a first-party service, so it is a Microsoft tool, and it has the ability to work with other extensions for streaming workloads. So if you couple Synapse with Event Hubs and Stream Analytics, there was recently announced some pretty cool optimization for Stream Analytics in Synapse. You could also use it in conjunction with Databricks. That's another capability. And down the road, as the Spark clusters become GA and more capability gets added, there may be some options there as well. As of this recording, there is no built-in streaming capability in Synapse itself. Snowflake has none. It's not intended or designed for hot path. There may be down the road, but as of this recording, again, there is nothing. Databricks is generally accepted as one of the best options here. Again, you can run it with Synapse and Event Hubs and Stream Analytics, Kafka to pull in the data. You've got some good solutions there. But what I would say is that if you're familiar with the development environment, Databricks is probably the best option here. And it also simplifies your architecture because you're really only using one tool as opposed to multiple tools with the Synapse environment, 3 or more. Okay, so ad hoc data discovery is our next category. And I would say again here that Synapse and Databricks are tied for the most capable options. And, when we look at the Synapse environment, the tooling that we use for this is called Polybase, or newly branded as data virtualization, which that term is coming through on a lot of our database products. So you'll see it in SQL and you'll see it in Synapse and some of the others. And what this allows us to do is to connect to a Hadoop-based file system and pull data from those file systems, Parquet being the current flavor of choice. We'll see some more support down the road. I believe we just released support for ORC file type. I'm sure we'll see Avro, as those are very popular standards. But in essence, you can connect to those external sources, and you can then pull that data into memory using data virtualization. It's considered an external table when you hang it off of Synapse. Or you can use a create table as select statement or a CTAS statement and bring that data right into your data warehouse as a table. In Snowflake, there's no capability for doing any kind of ad hoc data discovery. You essentially have to run it as if it's a data warehouse, import the data into the database that you're using, and then run any of your queries against it. And then finally, Databricks, again, comes down to the interface, right? So if you're comfortable with that code-driven, CLI-driven interface, you've got a great experience here. You can connect into Azure Data Lake Store and some other sources via API, pull that data into memory, or bring it in and persist it as part of Parquet. You can also run some lighter workloads on ADLS that can help with some of this and helps to optimize what you get for results. And they're adding more features to ADLS as well to help with some of these types of workloads. So in this case, Databricks and Synapse are probably on par. Databricks having a little more history with this type of operation though. So it depends on what your team looks like. Next, data science and machine learning workloads. So this one has to go to Databricks. Databricks is by far and away are designed around these types of workloads. And so this is, a built-in capability and a very, very strong suit for Databricks and very commonly used. Synapse, we introduced the Spark clusters, as I mentioned. There's going to be a lot of capability that grows over time. It is open source Spark that's running in the background. You can use a Delta Lake as part of that. But again, this is all currently in preview. And so, the real story, it's going to take a little while to kind of tell how strong of a tool it is from a Spark cluster standpoint. Otherwise, you can use some of the Azure machine learning tools that are available, AML Studio and automated machine learning and those capabilities, and you can use those with direct connectivity. But again, you're somewhat complicating your architecture, so it depends on what your requirements are to see what the best solution might be. Sorry, Snowflake, you just don't have this capability, wasn't built for this, and unfortunately, what we actually have to do is we have to pull the data back out of Snowflake in order to run these kinds of workloads. And, basically, the other option would be to multicast the data to a place where you want to run any kind of data science and machine learning workloads, and then you have to choose from one of the Azure tools or a Databricks, something like that. With Databricks, you've got the new notion of Workspaces 2.0, which they have just recently announced as part of their 7.x version of the tool. And this is offering a lot more capability around things like DevOps for data science, ML ops, and those types of things, right? So you've got some more integration now with Git and a lot of the different Git providers, Bitbucket and GitHub and Azure DevOps and those tools. Databricks is really coming strong and adding even more capability than there already is as part of this tool. Okay, next we're looking at business intelligence. So this one's kind of tricky because we look at pure business intelligence, and for me, as I define it, it is the ETL, it is the data warehouse, and it is the presentation layer. When it comes to those three elements, I think that Synapse has got the best here. And the reason I say that is because we have the native integration and development of Power BI within your Synapse Studio environment. You've got the ETL tools, you've got the compute engines, and everything is integrated. So that just makes the business intelligent developer world a lot easier. As the product goes to GA, you're going to have more capability with regard to how you use things like source control and templates and those kinds of things. But right now, again, it's probably the most complete solution. And you also have the capability to push the results of your data to something like Azure Analysis Services for XMLA connectivity if you're not going to use Power BI. And then you could also put it to like a data lake and consume it if your presentation tool is going to allow you to connect to like a Parquet format or a CSV format or something like that. So great solution there. Snowflake, when you look at the pure data warehouse element and it being a great solution for that, that's a great basis for your business intelligence, obviously. And then it has some good connectivity for other tools. So, your Power BIs, your Tableaus, and all of the leading presentation tools, there's a lot of capability in there. And so, it's definitely a very good option for BI workloads, but you do still have that sort of ETL portion that's lacking a little bit. So I'm going to say this is kind of middle range. Now, Databricks is kind of TBD for me. The reason I say that is because there's a lot of interesting stuff happening with the Photon engine. They added Redash to the environment, which gives more traditional SQL developers a familiar environment for charting and things like that. You can connect into it with Power BI, but it feels incomplete right now to me. Certainly you have the ETL elements. You can use a Delta Lake, which guarantees your transactions, similar to that of a traditional data warehouse, and you can store those files in Parquet, and then you got, some nice features like time travel and some of that stuff. But it doesn't feel like a truly complete solution right now. If you look at the Delta Lakehouse and connecting to it with a third-party presentation tool or Power BI and those kinds of things, there is some capability there. It just feels slightly incomplete. So I'm going to say that's a TBD. I've covered the majority of the solutions that I feel are what are being asked of by our customers today. Now, we've got a ton of other tools in Azure that offer a great amount of capability. You think of the things like Azure Data Explorer and some of the recent acquisitions of things like SAS and other analytical tools that are somewhat industry focused and things like that. So there's really a great amount of offerings when we look at what's available. But really what I wanted to do was look at what the most complete solutions were and what I would consider as my first three choices when it came to these particular workloads. So from an overall standpoint, I give a leg up for a most complete solution to Azure Synapse. Now, this could be highly contested because, again, there are a lot of capabilities built in all three services. The reason that I say that Synapse is the most complete solution is you really have that end-to-end story, and you have the native connectivity for all of the machine learning and data science workloads, as well as being able to, down the road, use the Spark engines to really combine your big data and data warehouse needs into one solution. So the reason I give a slight edge to Synapse is because you have the ability to report directly and build your reports directly with Power BI to then publish those to your Power BI workspaces or whatever you're going to use those for. Now, you can connect to Databricks with Power BI. However, you can't develop it in the same environment. And with Databricks, you have to have that compute running in order to connect to it with Power BI, whereas you can use XMLA endpoints and publish directly to Power BI data sets in the background, or you can use Azure Analysis Services to stage that model for delivery, and some of those costs can be mitigated as a result of this. With Databricks, you have all of the other portions of the total solution, but you can't develop the presentation layer. Now, Snowflake, again, is a great opportunity for a data warehouse environment, and purely that's what it's doing from a pure compute standpoint. But it's really lacking in some of the other areas that I've discussed here, and so I would not put that as a tier A solution or a top choice. The big delineation, again, between Databricks and Synapse is what does your team have familiarity with, right? When it comes to reporting, it's a presentation layer thing no matter what you do. Whereas with the development and all of those other areas, it really kind of depends down with what your company is used to and what they're comfortable with. If they came from the open source world and they've got a ton of Hadoop and Spark history, great. That's probably your best solution. Now, if you are looking at what might be a totally visual environment, sort of like the next stage, next evolution of your on-premises SQL and SSIS and those types of solutions, or other graphical tools, it's probably going to be Synapse as a better solution. That wraps up what I wanted to cover today. I hope you found this valuable. Please ask questions below. Let me know what you like about this, what you don't like about this. I really try to help out and offer as many solutions as we possibly can in an unbiased way, in the way that I'm seeing customers work with these various tools. Really appreciate all the opportunities that people are taking to share and like and comment and subscribe. It really helps out, and it's really motivating to keep putting some of this stuff out for y'all. So thanks again. Thanks for watching. Have a great day. Bye.